I'll say. So last time we had talked about two things. We had talked about graphing sine and cosine functions, and then we had talked about going from the graph of a sine or cosine function and generating the equation, right? And I'd asked you guys to work on worksheet 1. Do you guys, are there questions from that to start? Amy.
Could you just review the transformations again?
The transformations again?
Yeah, it was like on the first part of the worksheet.
Okay. All right. Okay. Yes.
For the C, you put C as greater than 0 rather than C as less than.
Thanks.
Wow. Okay. Mr. Cool, you did it for the horizontal stretch and straight
No, those are supposed to be ones.
Oh.
For the vertical stretches.
Oh, I thought that was a 0. My bad.
Oh,
I'm like.
yeah, that one should be a less than. Thank you. Been fighting with my stylus all day. It's been winning. Yeah, Sergio?
If you're done, let me.
Amy, that's what you wanted, right?
Yeah.
Okay. Yeah, no problem.
Can you like 14?
From worksheet 1.
Yeah.
Okay. So I would start by identifying my values for A, C, H, and K to start. So A is 2, C is 2, H is 0, and K is 1. Cool with that?
Yep.
So the amplitude is just the absolute value of A, so that's 2. The midline is y equals K, so that's y equals 1. The period is 2 pi times C, or the absolute value C, I should say. So that's 4 pi. And the frequency is 1 over the period. So that's 1 over 4 pi. And then to write my map, I do Cx plus H, Ay plus K. And then I'm going to use my key points for sine, which we gave you in the notes. That's not something I'd expect you to memorize. Those kind of things would be given to you. And then I just plug things in. So that's a 2 there. Oops, negative 1. No, that was right. Oh, that's why. Good golly, Mr. Kulik. Jeepers creepers, great googly moogly. Writing things down in the wrong spots. Okay. Yeah, so like 0, 1, pi 3, 2 pi 1, 3 pi negative 1, 4 pi 1. So that's 1 period. And then I would just kind of continue by extending this. So the next spot we're up here, and then back down to there, down there, back there, and I guess this one we'd be going down to there. No, I'm just kind of extending, right? Like I went, so I'm starting a new cycle, so I go to max, so I did my max, and then I go back to the midline, then we went down to a minimum, down to the minimum. So I'm putting them like at the same kind of spots that I did before. So you're just kind of, you're eyeballing a little bit, but it's not really like estimating. You know where it's going to be at. And like you put them, you know, it's, I guess it's estimating in the same way that like I estimated like where 1 was, but all the x coordinates, there's a grid line, so it's not really an estimate. You know what I mean? But that's the gist of it. So that's not too bad, right?
No, it's not. I don't know. It's just that I did the wrong homework.
Yeah. Well, you know. This one, all the grids are pre-made for you, so it's a little bit easier.
Right. So on that one homework that I was trying to do, so like when you had you had like
You start the same way. You just, when you draw your grid,
they'd go like the other way.
you know, you're going to go, I don't know, like pi over 2 pi, and you just dot it out to 4 pi, and dot it out to negative 4 pi, and then just draw your.
It's just you didn't give us the graph.
Yeah, I didn't give you a graph, so you just have to draw your own and do. You'll have a lot of extending to do, I think, on that one, but you know, it's no big deal. It's not really different than that one. Just you have to do your own drawing. But overall, like, again, same kind of thing. It's okay with that stuff? Yeah, Natalie?
I just have one question on homework.
Sure, what's up?
Number 8. I'm just having trouble finding the right.
8. Well, the C is going to be negative 2. So again, what we're looking for is something in this form. I noticed that this inside doesn't look like it's the same form as that inside, because the leading coefficient in the red is on the x is 1. Here it's negative 1/2, right? So I'd start by factoring the negative 1/2 out. When I divide by a negative 1/2, that's the same thing as multiplying by a negative 2. So it becomes a positive pi over 5. So my C there, well, my 1 over C is negative 1/2. So C is the reciprocal. So negative 2. Is that okay? Okie doke. Yeah, let me grab this real quick. I want this example. So the other thing we did last time, we did this graphing stuff. And we also did an example of where we go from a graph back to the equation. So let's do another example of that. Because you'll do some of this in the next set of homework, so we should go through this one more time. So, as we mentioned before, there's kind of infinitely many answers for one of these. There's correct answers where you write it as a cosine function, and there's correct answers where you can write it as a sine function. You may be asked to do one or the other. You might be asked to do both. We're going to get an answer in each form. Everybody's okay with that idea? Okay. I said last time that the thing that I like to start with and what I recommend you guys starting with is finding the value for k. To do that, all we have to do is locate the midline. So if I just kind of use my eyeballs, it looks like that cuts the graph in half. You guys agree with that? So that tells me that the k is 1. And that's nice because the k is the same for both sine and cosine functions. That part doesn't change when we're doing one of these anyways. Next thing I like to do is find the amplitude, which is like the distance from an extreme point back to that midline. So here that amplitude appears to be 3. And again, notice that I'm writing the absolute value of a is 3. I don't know whether for the answer that I'm about to write, whether I'm going to need to use positive 3 or negative 3. We'll sort that out in a few moments. But I'm just going to write just absolute value of a is equal to 3. Next, I'm going to figure out the value of c by looking at the period. So I like to go from like extreme point to extreme point to find a period. So like min to min or max to max. Just mostly because they're easy for me to identify what the points are. So here I went from negative 0.25 to, or negative 1.25 to negative 0.25. So that tells me that's pi long. Everybody's okay with that? And I know the period is 2 pi times the absolute value of c. So that tells me that the absolute value of c is 1/2. And I'm going to, in my answer, always assume the c is positive. There are correct answers where c is negative, but I don't think it ever makes it any easier to choose a negative c, so I always go ahead and just choose it to be positive. Mr. Salick, what can I do for you? No, he's in 8th hour now. His schedule had changed. Yep. Everybody so far so good. Okay, and then the most challenging part tended to be finding the value for h. So to do the value, or to find the value of h, I'm going to be comparing a point from the parent function to a point in the transform function. When choosing a point from the parent function, I would prefer to pick a point whose x-coordinate is 0. So for cosine, that would be 0, 1. If I looked at the graph of cosine, that's a maximum. And I'm going to compare that to some other extreme point in my transform function. So any maximum or minimum would be fine. So I could pick any of these maximums or any of these minimums. It doesn't really matter. Let's say, for the sake of argument, we pick that one. It doesn't matter. So that one is pi over 4 comma 4. And I just read that off the xy axis. And I noted that that was a maximum also on my transform graph. So comparing the type of extreme point tells me that the A is positive, since they're the same extreme point. And the x-coordinate from my transform point is give me my value of h, so long as I'm using a point for my parent function whose x-coordinate is 0. But that's all I need. So I can say y equals 3 cosine of 1 over 1/2 x minus pi over 4 plus 1 is one possible answer. There are many. Yes, sir.
When we do write out the final answer, do you want to multiply the 1 over 1/2 in?
Yeah, so if you wanted to simplify this down and multiply the 1 over 1/2 is 2 and distribute the 2 through, that's fine. I don't need you to do that.
Okay.
But it's fine if you do.
Okay.
You know, I'm not going to be super picky about that sort of thing, because it's, you know, whatever we're worried about. Can you write the equation? Not can we simplify and express? You know,
Yeah.
Sergio.
Can you explain where you got the point for parent function and transfer function?
So I chose both of them. So my parent function, we had those 5 key points that we had mentioned in the last lecture.
Mm-hmm.
I picked the one whose x-coordinate is 0.
Okay.
That makes the arithmetic just a little bit easier. That's the only reason why I'm choosing it. And then since that is a maximum, so if you look at the graph of cosine, there's 1, 0, or 0, 1, excuse me. So it's a maximum, it's a high point. So then I need another extreme point for my transform function. So any max or min is okay.
Okay.
We chose this one just because. Any of them would have been fine. Changes your answer, but that's fine. No big deal. Does that feel all right?
Yeah.
Okay. Yep. And again, lots of different possible answers here, right? Natalie?
That's a quick question. How did you find C again in the graph?
So I solved one period is 2 pi times the absolute value of c. And the period in this graph was pi, so I divided both sides by 2 pi to solve that equation for c. Is that okay? Cool. Okay, for sine. Again, I'm going to choose a point from the parent function, preferably one where the x-coordinate is 0. That would be the point 0, 0. As we mentioned, there was 0, 0 is a midline point. And there are 2 different kinds of midline points. So just to kind of show you that again. So 0, 0, if I look preceding that midline point, there's a minimum. And following that midline point, there's a maximum. So it's min, midline, maximum. But if I had instead looked at this midline point at pi 0, here it goes max, midline, minimum. So there's 2 different kinds of midline points. That's okay, but we need to make sure when we're doing this, we have to make sure that we're aware of that. So then the parent function, we did the midline point that goes min, midline, max. In the transform function, I'm going to find another midline point, and I have to make sure I check what type of midline point is it. Is it the min, midline, max, or is it max, midline, min? So I'm going to go to my graph, and I can pick any of these midline points that I want. It doesn't matter. Right? So we have lots of choices. Let's say for the sake of argument, I chose that one. Everybody okay with that? Just because the numbers are small. You know what I mean? Or convenient. So that's 0, 1. And preceding that is a minimum, and following it is a maximum. So here, it's the same order. So it tells me the A is positive. And since this x-coordinate on the parent function is 0, the x-coordinate for my transform function gives me h. And that's everything I needed. And again, you could simplify that down if you wanted to. I chose to write it this way so it's obvious like how I plugged everything in, right? Since they're notes, you know. Lexi.
So could A change to being negative then if we chose a different method?
Yeah, absolutely. So for example, had we chose, say, this midline point at pi over 2 and 1, that one is a max midline point min, so there the A would be negative.
Okay.
And the H would have then been pi over 2. Does that make sense? On kind of how we're determining the signs of the A's? Okay. Good. We feel okay on this? Again, we talked about this a little bit last time, right? So we just did another example. Nothing new happened here, just wanted to review because it's, you know, it's a new process, right? So, and we didn't practice it on the homework, so before I ask you to do some more on it, like run through another example, didn't hurt anything. The next thing we want to talk about is something that's slightly, or can be slightly more difficult. Here, we're going to go from a description to an equation. So this can be slightly more difficult because you're given less information, right? The graph, you have every point on the graph. Here in a description, you just have some information. Maybe you have some of the points, maybe you don't. Maybe you just have some information about the, you know, the graph or whatnot, and it can be challenging. Let's run through a couple of examples here. So let's say that we're told that our the amplitude is 3. The period is 6, and we pass through the point -5 and 7. So here we're not given the whole graph, right, like we were in the previous. But we're going to use a lot of the same techniques here. So the amplitude, square away, that gives me the possible values for A, right? Where A can be positive or negative. Everybody's cool with that? The period I can use to get C. And as I've said a couple of times now, I'm just always going to pick C to be positive. Not that there aren't correct answers where C is negative. I just don't find them any easier to get than if I just choose C to be positive. Everybody's okay there? So somehow this last piece, this point, should be able to give me my values for H and K, and the sign for A should all come out of this last point. Do we know what kind of point this is? Is it a max? Is it a min? Is it a midline point? The answer is yes. It could be any of those, right? All the graph has to do is go through it. So we have the freedom to kind of assign that point anywhere we want on our graph. Oh, okay. Well then, that's awfully nice. So let's say I'm doing a sine graph. I know from the parent function we like to use 0, 0. Because it's a midline point. And the transform function, well, let's just say that 5, 7 is the same kind of midline point. Doesn't matter where that point is on the graph, it just has to be on there somewhere. So that tells me that the A is positive. It tells me that the H is negative 5. And because the y-coordinate is 0, it also tells me the K is 7. So that's one possible answer. What if instead we had chosen to use cosine here? Well, this is be a little bit more difficult, but not a ton more difficult. So for cosine, we like to use 0, 1, which is a maximum. In our transform function, well, I have the freedom for negative 5, 7 to be any point I want. So why wouldn't I just pick it to be a maximum? So that gives me a positive 3 for A. Because this is 0, I know this is negative 5, or H is negative 5. The K, though, is not going to be quite as trivial. So to find K, let me just remind you of what we're about to do. So we know to transform a point from the parent function to the transform function, we do this, right? Everybody's okay? So I know that A times y from the parent function plus K should give me the y from the transformed function. Everybody's okay with that idea? So my A is 3. The y from my parent function is 1. K is what we're looking for. And the y from my transformed function is 7. So K must be 4. What do you guys think? What if we take the same situation but let's say this time it has a minimum at -5.7. So, yes.
I just want to make sure with the last question, where'd you get the y from
The 7?
Yes.
It's the y coordinate of the point that it's going to. Yeah, no problem. Sure. But that makes sense, right? Yeah, okay. So almost the same problem here, but this time we're telling you that that point must be at a minimum, right? Everybody's okay? Well, these parts aren't going to change. Everybody's okay there? Now, if I have my choice here between a sine or a cosine function, which one's going to be easier? Cosine. Why? Because the parent function's point that we prefer to use is an extreme point, right? Sine's parent function point that we prefer to use is a midline point, so we'd have to pick a different point from sine, which makes it a little bit more tedious arithmetic-wise. Not a lot, but a little. We'll do it both ways so you guys can see. So let's do the cosine way first. So the parent function goes 0, 1, which is a maximum, to -5.7, which is a minimum. So since we're going max to min, I know the a needs to be negative. The h is going to be -5. And to get my k, that's going to have to be 10. Not a difficult equation to solve for k, but again, you know, it's not nothing. And if you're not thinking about, like, how do I get the k again? You know, it can be challenging for sure. Amy?
So for the you always just use 0, 1 cosine?
No, but it's my preference.
Okay.
So if I have another extreme point that I can use, then I can use 0, 1. But if this was a midline point, I couldn't use 0, 1 anymore. Because when I'm doing the mapping that I'm describing, I have to go like extreme point to extreme point or midline point to midline point. I can't take a midline point and take it to an extreme point or vice versa.
So then to find the midline point, you still have the graph.
You'd have to, well, you'd pick one of the different key points from cosine.
Oh.
Yeah, which is what we're going to have to do with sine, right? So normally for sine, we want to use the point 0, 0, right? That's what our preference would be. However, 0, 0 isn't an extreme point, it's a midline point. So we can't use it in this problem. We have to pick an extreme point from my key points for sine. So I could use, say, for example, pi over 2, 1, which is a maximum. To send to this minimum. So that tells me the a needs to be negative. And now I'm going to have to solve for h and k separately. So my c was 3 over pi times the x from my parent function plus h should give me the x from my transformed function. So h is going to be like negative 3.5. And then similarly, the a times the y from my parent function plus k should give me the y from my transformed function. So that tells me k is 10. Amy.
Could you just explain how we figure out if A is less than 0 or greater than 0?
Sure. So if I'm going to the same kind of extreme point, a should be positive. If it's going to the opposite kind, it's going to be negative.
So when you say like opposite kind, do you mean it will come from like max to max?
So if it's max to max, a would be positive. If it's going max to min, a would be negative.
Oh, okay.
Or if you're talking about midline points, I think we did one somewhere. No, maybe we didn't do one. But if your midline point order was different, here the midline point order is the same. That's why the a is positive. If you had the opposite order for your midline point, then a would have to be negative. Yeah. Jack, you had your hand up.
Could you just repeat the equation used to find
Sure. So in general here, as an aside, so we know xy goes to cx plus h, ay plus k, right? So I can say c times the x from the parent function plus h should give me the x from the transformed function. Right? That's how we transform our points. Or if I wanted I could say a times y from the parent function plus k should give me the y from the transformed function. Because that's how we make those transformed points, right? We do that equation on the parent function point. Does that make sense? So it's like an equation we already know, kind of. But we can write that out explicitly like that for us. That's probably helpful to see. Emily? Of course. Jack, you happy with that?
Yeah.
Okay. Sure. Well, let's look at another. Let's do something maybe a little bit more challenging even. Let's just say we have a minimum at negative 3, 4, and we have a maximum at 7, 12. So I'm going to start by kind of drawing a little bit of a picture. I think that'll help me get a feel for what's going on, and it'll help justify some of the things I'm about ready to do. Okay? Because here this is very different. We don't have any of the normal or of the specific measurements to start with, right? So let's see. Negative 3, 4 is maybe there. And 7, 12 is maybe up there, right? So like this is the piece that we have, or that we kind of know about. Now I drew this where the minimum and maximum that they've given me were consecutive, right? Do I know that they're consecutive for sure? No, but do I know they're not consecutive? No, so I can draw them consecutively and it's going to be fine. It'll still meet the criteria. Could you put like another bump, more than one bump in between them? Yeah, but like, why would you want to? I don't know, but you could have if you wanted. It wouldn't have been wrong. It don't make it any easier, that's for sure. Everybody's okay with the picture I've drawn though? Okay. So I'm going to start the same way. I'm going to look for that midline. For this problem, the midline looks like it would be right around there. So it's going to be halfway between the y coordinates, right? So it's basically going to be the average of the y coordinates, right? That's halfway in between them. So I'll just do like y max plus y min divided by 2. So in this case, 12 plus 4 over 2. That's 8. Everybody's okay with that? Okay. The amplitude is half of this distance from max to min, correct? So since it's half of a distance, it's going to be y max minus y min over 2. Everybody's okay with that? Right? If I want to know how far is it from 4 to 8, well, I have to do 8 minus 4, right? So I'm subtracting. You guys good? So let's calculate the period next. So from here to here is how much of a period? Looks like half, right? And that's going to be x to the right minus x on the left. Oh, I'm sorry. Left. No. Yeah. Right minus left. I'll do it that way. Is that okay? Because depending on which one is listed first, or which one comes first, is the order that you're subtracting. Or you could just put an absolute value around the whole thing and just do one minus the other. That's fine too.
What's the letter under?
R and L is the two x's, or the two subscripts that I wrote. So I know that half of a period is 10. So, and I know one period is 2 pi times the absolute value of c. So pi c is equal to 10. So if I divide both sides by pi, the absolute value of c is 10. And I know I'm just always going to use the positive c. So we're good there. Okay, so we have our amplitude, our k, and our c. Now let's find our h and the sign for a. Same way we have before. In this problem, would it be easier to use sine or cosine? Cosine. Why? We're given maxes and mins, right? That'll make life a little bit easier. So 0, 1 is my preferred point to use, and I like it because it's relevant this time because it's a maximum. And I could map this up with either one, it doesn't matter. Let's just say for the sake of argument, I'm going to use the first one, -3, 4, just because I wrote it down first. That was a minimum. So that tells me what about the sign for A? Has to be negative, so A is -4. And it tells me what about the value for H? It's -3. So there's everything I need for my cosine. What was the K? Was it 8? Yeah. If we did this as a sine function, we have to use a max or min from the key points of sine, which makes it a little bit more tedious. So maybe we use pi over 2, 1, which is a maximum. Let's just, for the sake of argument, match it up with that same minimum. So again, that tells me that A is negative. And then to find the H, I need to do C times x from the parent function plus H should equal x from the transformed function. So my C was 10 over pi. The x from the parent function is pi over 2. H is what we're looking for and has to equal -3, which is the x coordinate for my transformed function. So the pi's cancel and I'm left with 5. So when I subtract the 5 over, I get H is -8. And there we're all done. So I just want to point out that here the arithmetic is never really difficult, right? Now you have to understand what's going on. You have to use a little bit of common sense. It helps if you can kind of get a visual picture of what's going on. Like I'm a drawing person. I like to draw a picture and make sure that it makes sense what I'm doing mathematically with what I've drawn. So that's certainly something I encourage you to really think about, like, okay, K is halfway in between the max and min, so like whatever my value of K is better be halfway in between, right? So you can always kind of check your work as you're going. Just make sure you're being careful, but overall while it can be a lot of steps, because there's a lot of things to figure out, none of the steps are like overwhelmingly technical, but we do stuff for reasons that are not like numeric reasons or algebraic reasons. They're like geometric kind of reasons, right? So they don't have work to show with them. You just have to remember, like, oh yeah, I can't do that. I can't send a max to a midline point. I have to use, or when I'm sending max to min, I have to remember to flip the sign, or, that are kind of like geometric reasons. Does that make sense? Okay, this is where we'll stop for today. So you guys should be able to do worksheets 2 and worksheets 3. I would do worksheet 3 first. I think it's a little bit easier than 2. So worksheet 3 is the one where you're going from graph to equation. And then worksheet 2 is where you're going from description to equation. And some of these are quite tricky, so don't feel bad. If you're like, I'm stuck on this one, we can always come back and talk about stuff next week. Not a big deal. Reminder that we don't meet in person on Wednesday. Wednesday's an asynchronous day. I've already made the video and posted the link for that day. It's like 15 minutes, but it's just me going through more examples of this stuff. So if you feel good about what you're doing, you're more than welcome to just skip it. And go just start working on your homeworks or whatever. Like it's not going to be decidedly different than today's lecture. If you think you got it, there's not a whole lot more to be gained from watching. It's only like 15 or 20 minutes. I tried to make it pretty edible. Because I know sitting there on the computer watching a video is a lot different than being in person, trying to pay attention. So tried to keep it brief. So just to reiterate here, the homework checks. So for this weekend, the 10th, I'm looking at just worksheet 1. The 17th is next weekend. There I'll be looking for worksheets 2 and 3, as well as 1 through 14 from the book. So on Wednesday, you can watch the video if you're like, yeah, I just want to watch a little bit more examples of this stuff. I'm still kind of a little shaky. Totally fine. Or you can just dive right into starting the homeworks. And all that stuff is up on My Notre Dame, reflected. So let's probably add that to the list here. Everybody happy with that plan? Seems reasonable.